Good morning! Welcome to Valenzuela Live Mathematics for Grade 8. I am Sir Eldy Francisco from Jenny De Leon National High School, your FA Live teacher for the day. If on the previous topic we have learned a lot about factoring polynomials with greatest common monomial factor or GCMF, difference of two squares or DOTS, sum and difference of two cubes or SDTC, today is just a continuation of the lesson. We are going to discuss other types of factoring polynomials, which are factoring perfect square trinomial and general trinomial. And for our learning competency, we are now on the second week of the first quarter. And at the end of the session, you should be able to factor perfect square trinomial and general trinomial, and solve problems involving factors of polynomials. But before we begin, let us start this discussion with an activity. The title of the activity is I Feel You. We are going to fill in the blanks of the missing terms of each square of binomials. Right. If you know the answer, please type it at the comment section below. Okay, so let's start. 1. The square of binomial x plus 2 is equal to x squared plus 4x plus blank. Comment your answer. Very good. The answer is 4. Next. The square of binomial x minus 6 is equal to x squared minus blank plus 36. Go! You are correct. The answer is 12x. 3. The square of binomial x plus y is equal to blank plus 2xy plus y squared. Go! Good. The correct answer is x squared. Next, the square of binomial 2x minus 3 equals blank minus 12x plus 9. Go. Alright. Excellent. 4x squared. Last, the square of binomial 3x plus y is equal to 9x squared plus blank plus y squared. Go. Very good. The correct answer is 6xy. And now, let us observe the products or polynomials done in the previous activity. These are the products. And we are going to answer the following questions. Are you ready? Okay. 1. How many terms do we have in the product of each square of binomials? How many terms? Very good. We have 3 terms. Next, what is a polynomial with 3 terms? Yes, of course. That is a trinomial. Next, what can you say about the first and last term of each trinomial? The first and the last term. Very good. They are both perfect squares. Now, try to observe the second terms in the product with respect to the first and last terms. Try to observe the second terms with respect to the first and last terms. Alright, yes, you are correct. Regardless of the sign, it is twice the product of the square root of the first and last terms. And because of that, those products are what we call a perfect square trinomials or perfect square trinomials or PST. So, what is a perfect square trinomial? It is an expression obtained from the square of binomial. And here are the guides in identifying a perfect square trinomial. 1. The first and last terms must be perfect squares. 2. The signs of the first and last terms must be positive. And 3. Regardless of the sign, the middle term is twice the product of the square root of first and last terms. Let us emphasize the third guide. Let us use the expression x squared minus 12x plus 36 as an example. First, let us get the first and last term. We have x squared and 36. Then, get the square root of those terms. But take note, we will get only the principal square roots of those terms. So, square root of x squared is x. Square root of 36 is 6. Then, getting the product of those square roots of first and last terms, we have 6x. Then, twice it. And last, we will have 12x as the middle term regardless of the sign. Now, are you ready for our next activity? The name of the activity is Getting to Know Me Better. You are going to identify if each polynomial is a perfect square trinomial, PST, or not. Click like react if it is PST, and react if it is not. Let's begin. X squared plus 8x plus 16. PST or not? React now, like or haha. Very good. The answer is PST. 2. X squared minus 6x minus 9. PST or not? React now. Very good. The answer is not, because the last term is a perfect square but not a positive number. Next, 8x squared plus 10x plus 25. PST or not? Very good. The answer is not, because the first term is not a perfect square. Alright, number 4. 25x squared plus 10x plus 1. PST or not? Very good. The answer is PST. Last, 144x squared plus 8x plus 16. PST or not? Very good. The answer is not, because regardless of the sign, the middle term is not twice the product of the square root of the first and last terms. At this point, remember that factoring is the reverse process of multiplication or getting a product. After we identify a perfect square trinomial, let us now proceed in factoring a perfect square trinomial. The factor of perfect square trinomial is the square of a binomial. That is written in this form. The square of binomial a plus or minus b. Remember these, learners. Don't be confused about this. The square of binomial is also equal to two identical factors. Therefore, the square of binomial a plus b is equal to quantity a plus b times quantity a plus b. And the square of binomial a minus b is equal to quantity a minus b times quantity a minus b. We have here the steps in factoring perfect square trinomial. First, extract the square root of the first and last terms to get the first and last terms of the square of binomial. Next, the sign between the two terms of the square of binomial is the same as the sign of the middle term of the perfect square trinomial. This is the representation. A squared plus or minus 2ab plus b squared is equal to the square of binomial a plus or minus b. Now, let us proceed to the example. Factor x squared plus 16x plus 64. Is the given expression a perfect square trinomial? Okay, yes, very good. This is a perfect square trinomial. So we are expecting our answer is in this form, or a square of binomial. Okay, let's proceed to step number 1. Extract the square root of the first and last terms to get the first and last terms of the square of binomial. So the first term is x squared. So square root of x squared is x. The last term is 64. The square root of 64 is 8. And next step, the sign between the two terms of the square of binomial is the same as the sign of the middle term of the perfect square trinomial. The sign is plus. So copy the plus sign. Very good. Therefore, x squared plus 16x plus 64 is equal to the square of binomial x plus 8. Example number 2. Factor 4x squared minus 44x plus 121. Obviously, this is also a PST. With that, we're expecting that the answer is a square of a binomial. Now, let us have step number 1. Extract the square root of the first and last terms to get the first term of the square of binomial. So we have square root of 4x squared is 2x. And square root of 121 is 11. And then, copy the sign between the, or copy the sign, or the sign between the two terms of the square of binomial is the same as the sign of the middle term of a perfect square trinomial. And that is a minus sign. Very good. Therefore, 4x squared minus 44x plus 121 is equal to the binomial, or the square of binomial 2x minus 11. Yes, it's too easy. Now the question is, can we factor some trinomials which are not a perfect square? Hey, there are general trinomials in the form ax squared plus bx plus c that are factorable even if it is not a PST. Those are what we call quadratic trinomials. Quadratic trinomial is also defined as a second-degree polynomial with 3 terms. Moving on, we are going to factor quadratic trinomials in the form ax squared plus bx plus c. We can divide this discussion of these factoring quadratic trinomials into 2 parts. Case 1, a quadratic trinomial where a is equal to 1. And case 2, a quadratic trinomial where a is not equal to 1. Let us proceed in factoring quadratic trinomials where a is equal to 1. The factors of quadratic trinomial are 2 different binomials. These are the steps in factoring quadratic trinomial where a is equal to 1. Step 1. Find 2 factors of c whose sum is the coefficient of b or coefficient b. Step 2. Using the form quantity x plus blank times quantity x plus blank, fill this in with the 2 factors found in step 1. Representation, x squared plus bx plus c is equal to quantity x plus m times quantity x plus n, where m and n are factors of c whose sum is b. Let us move to example 1. Factor x squared plus 5x plus 6. Step 1. Find two factors of c whose sum is the coefficient b. So, what are the factors of 6 whose sum is 5? Then, let us list down all the factors of 6 and the sum of its factors. Yes, we have 1 and 6 as the factors of 6. So, 1 plus 6 is 7. We also have 2 and 3. 2 plus 3 equals 5. And we also have negative 1 and negative 6. Negative 1 plus negative 6 equals negative 7. And we have negative 2 and negative 3. Negative 2 plus negative 3 equals negative 5. And now I think we have the factors of 6 whose sum is 5. Yes, very good. That is 2 and 3. Next step. Step 2. Using the given form x plus blank or quantity x plus blank times quantity x plus blank, fill in the two factors found in step 1. So we have now x plus 2 times x plus 3 or quantity x plus 2 times quantity x plus 3. Therefore, x squared plus 5x plus 6 equals quantity x plus 2 times quantity x plus 3. Example number 2. Factor x squared plus 3x minus 18. From step 1, what are the factors of negative 18 whose sum is 3? Again, let us list down all the factors of negative 18 and the sum of it. And the sum of its factors. Okay. So, we have 1 and negative 18. 1 plus negative 18 is negative 17. We also have 2 and negative 9. 2 plus negative 9 equals negative 7. Yes. Okay, very good. We also have 3 and negative 6. 3 plus negative 6 is negative 3. Yes, we also have 6 and negative 3. 6 plus negative 3 equals 3. Alright, we have 9 and negative 2. 9 plus negative 2 equals 7. Yes, we also have 18 and negative 1. 18 plus negative 1 equals positive 17. And we have now 6 and negative 3 as the factors of negative 18 whose sum is 3. Step 2. Using the given form, fill in the two factors found in step 1. Filling in, we will have x plus 3 or quantity x plus x or quantity x plus 6 times quantity x plus negative 3. We all know that we can also rewrite x plus negative 3 into x minus 3. Therefore, x squared plus 3x minus 18 equals quantity x plus 6 times quantity x minus 3. For example number 3, let us factor it mentally. Factor x squared minus 8x plus 12. From step 1, what are the factors of 12 whose sum is negative 8? Let us think. Yes, very good. The factors are negative 2 and negative 6. And last step, using the given form, fill in the two factors found in step 1. So we will have now x minus 2 times x minus 6. Therefore, x squared minus 8x plus 12 is equal to the quantity x minus 2 times quantity x minus 6. Example number 4. Factor x squared minus x minus 12. So from step 1, what are the factors of negative 12 whose sum is negative 1? Try to think. What are the factors of negative 12? That the sum is negative 1. Very good. The factors are 3 and negative 4. And last step, using the given form, fill in the two factors found in step 1. And we will have quantity x plus 3 times quantity x minus 4. Therefore, x squared minus x minus 12 is equal to x, or quantity x plus 3 times quantity x minus 4. Let us now move to case number 2. Factoring quadratic trinomial or quadratic trinomials where a is not equal to 1. There are different ways in solving this case. First, we have the grouping method, where you are going to extract the middle term and regroup the polynomial to have a common binomial factors. Then we also have the trial and error, or what we call TAE method, or also known as guess and check, where you are going to try until you get the correct factors. And we also have the AC method, and this method will be used in our discussion for today. So here are the steps in factoring quadratic trinomial where a is not equal to 1 using AC method. Step 1, factor out any common monomial factor if possible. 2, multiply the leading coefficient A and the C. 3, find the factors of AC whose sum is the coefficient B. 4, using the form quantity AX plus blank times quantity AX plus blank, fill this in with the two factors found in step 3. And 5, divide each binomial by its GCF if possible. Now, let us have example number 1. Factor 8x squared minus 14x plus 3. Step 1. Factor out any common monomial factor if possible. Is it possible? Very good. Not possible. Next, multiply the leading coefficient A and the C. Okay, our A is 8 and C is 3. By multiplying, we get AC equals 24. Step 3. Find two factors of AC whose sum is coefficient B. Our coefficient B is negative 14. So what are the factors of 24 whose sum is negative 14? Very good. Those are negative 12 and negative 2. Next step. Using the form AX, using the form quantity AX plus blank times quantity AX plus blank, fill this in with the two factors found in step 3. Our A is 8. So we have 8x plus blank times 8x plus blank. Filling in, we will have 8x minus 12 times 8x minus 2. And last step, divide each binomial by its GCF if possible. The first binomial factor, 8x minus 12, has a GCF of 4. So dividing 4 to both terms, we get 2x minus 3. And the second binomial factor has a GCF of 2. Then by dividing it to both terms, we obtain 4x minus 1. Therefore, 8x squared minus 14x plus 3 equals quantity 2x minus 3 times quantity 4x minus 1. Example number 2. Factor 4x squared minus 6x minus 10. Step 1. Factor out any common monomial factor if possible. Yes, that is possible. Then, we have 4x squared minus 6x minus 10 equals 2, which is the greatest common monomial factor, times quantity 2x squared minus 3x minus 5. And we have now 2 as one of the factors of our given expression. Then, for 2x squared minus 3x minus 5, which is our new expression, proceed to the next step. Step 2, multiply the leading coefficient of the C, or leading coefficient A and the C. You are going to multiply. Again, our A this time is 2, our B is negative 3, C is negative 5. So, by multiplying A and C, that will become negative 10. Okay. And step 3, find the two factors of AC whose sum is the coefficient B. Obviously, that is 2 and negative 5. Okay. Next, using the form quantity AX plus blank times quantity AX plus blank, fill this in with the two factors found in step 3. So, we will have, very good, 2x plus 2 times 2x minus 5. And last step, divide each binomial by its GCF if possible. The first binomial factor can be divided by its GCF, which is 2. And the second binomial factor is already on its prime. So we simply bring down. And we have now x plus 1 times 2x minus 5. Therefore, 4x squared minus 6x minus 10 equals 2 times quantity x plus 1 times 2x minus 5. Okay. Are you ready to solve problems involving factors of polynomials? Let us proceed in solving word problems involving factors of polynomials. These are the steps in solving word problems involving factors of polynomials. 1. Representation. It can be a formula or mathematical sentence based on the problem. 2. Solution. Solve using different types of factoring polynomials and simplify. 3. Final answer. Express your answers completely. Let's start. Word problem 1. Last January 2020, the Valenzuela City's Baseball and Softball League Season 5 were launched. Unlike most team sports that play on a rectangular field, baseball is played on a four-cornered part of the whole baseball field, which is commonly known as the baseball diamond. Although it is called a baseball diamond, that part is actually a square. If the land area of the baseball diamond is expressed as x squared plus 20x plus 100, what would be the length of one side of it? This is the diagram or illustration of baseball field. And we have the baseball diamond. But actually, that is a square. Then, the area of the square based on the problem is x squared plus 20x plus 100 square units. Let us have now the representation. And because we are talking about the square and we have the given area, obviously, our representation is the formula of the area of the square, which is area of the square equals s squared, where s is the side. And for the solution, area of the square is equal to x squared, s squared. Solve for s. If area of square is equal to s squared, then x squared plus 20x plus 100 is equal to s squared. Reason? Substitution property. And by applying your learning in factoring perfect square trinomial, we obtain square of the binomial x plus 10 equals s squared. Then, since the quantities on both sides of the equation has the same exponent, therefore, the bases are equal by property of exponent. So we have x plus 10 equals S. And by symmetric property, S is equal to x plus 10. For final answer, the length of one side of the baseball diamond is x plus 10 units, where x is greater than negative 10. Because we are pertaining for the length which measure should be greater than 0. Next, problem number 2. At Kay Grande National High School, the two rectangular fences are to be constructed adjacent to each other for gardening with areas x squared plus 8x plus 15 square meters and 2x squared plus 7x plus 3 square meters as a project of TLE department. How long is the common side? This is the illustration. We have the first rectangular fence, the second rectangular fence, and we are looking for the common side. From the illustration, we can write now the area of each rectangular fence. For the first fence, we have x squared plus 8x plus 10 plus 15 square meter. And for the second fence, we have 2x squared plus 7x plus 3 square meter. Moving on, for representation, because we are looking for the common sides or common side of the two rectangular fences, and we have the given areas, we need the formula of the area of rectangle. Area of rectangle equals length times width, where L and W are the dimensions. Next is solution. Let us solve first for the dimension of the first rectangular fence, with an area of x squared plus 8x plus 15 square meter. By substitution from the formula, we obtain x squared plus 8x plus 15 equals length times width. And as you can notice, our area is a trinomial which is a quadratic trinomial with a is equal to 1 that can be factored as quantity x plus 3 times quantity x plus 5, and that is equal to length times width. Therefore, the sides of the first fence are x plus 3 meters and x plus 5 meters. Moving on, let us solve now for the dimension of the second rectangular fence with an area of 2x squared plus 7x plus 3 square meter. Again, as you notice, this given area is a quadratic trinomial where a is not equal to 1. And by applying our learnings about factoring this kind of polynomial, we obtain quantity 2x plus 1 times quantity x plus 3 equals length times width. Therefore, the sides of the second fence are 2x plus 1 meter and x plus 3 meter. And last, our common side is x plus 3 meter. So, for the final answer, x plus 3 meter long is the common side of the fences where x is greater than negative 3. And to wrap up our today's discussion, which you can also take a screenshot of the following important things to remember, we have now the steps in factoring perfect square trinomial. We also have identifying a perfect square trinomial. And our quadratic trinomial is divided in two cases. First case, a quadratic trinomial where a is equal to 1. And case 2, a quadratic trinomial where a is not equal to 1. And we also have steps in factoring quadratic trinomials where a is equal to 1. You also have steps in factoring quadratic trinomials where a is not equal to 1. And we have steps in solving word problem involving factors of polynomials, representation, solution, and final answer. Okay, let us now proceed to the question and answer part. If you have any question about the topic, you can type it on the comment box below. Okay, I received a question from one student through private message. Sir, are all quadratic trinomials factorable? Very good question. The answer is no. There are quadratic trinomials which cannot be factored, and those expressions are considered prime. If you have further questions about our topic, you can note down your questions and ask your subject teacher on your follow-up discussion tomorrow. And for our assignment, answer Mathematics 8, Quarter 1, Module 2, what's more, try this and keep trying. Okay. And that will be all for today. Thank you for listening and your active participation. Keep safe, everyone. Goodbye.